Welcome to the YMCA at San Francisco's Classroom for All. My name is Justin, and today we will be working on adding and subtracting fractions. In this activity, we will be covering the identity theorem, adding fractions, and subtracting fractions. Feel free to follow along now, or you could just watch and try the activity later on your own. So let's go ahead and get started. Okay, to begin, we're going to cover the identity theorem. So the identity theorem states that whenever you divide something by itself, it is always going to equal 1. So this also works if we go, let's say, 42 over 42. This is also going to equal 1. We can even use huge numbers such as infinity. So if we go infinity divided by infinity, that is also going to equal 1. So the identity theorem states that whenever you divide a number by itself, it is always going to equal 1. So this is going to be helpful later when we work with our fractions that have unlike denominators. So now that we've done the identity theorem, I'm going to go ahead and cross it off. We can move on to adding fractions. So to begin, we're going to start with a pretty basic one, but I'm actually going to show you 2 ways to solve the same problem. So to start, we're going to start with 1/4 plus 1/4. Okay, so I'm sure you all can do this already, but I'm going to show you 2 different ways to do it. And doing it with the basic problem is going to help us when we move on to more difficult fractions. So to begin, I'm going to show you how to solve this with a diagram. So let's do this. I'm going to make a box. Okay, and this box is going to represent one whole. So I'm going to break it up into 4 different parts to represent our 1/4. Okay, so here is our one whole, breaking up into 4 different boxes. So 1, 2, 3, 4. We're going to go ahead and fill in 1/4 for our first fourth. And then fill in another fourth for our second fourth. Okay, and now our answer is 1, 2. So 2 out of 1, 2, 3, 4. So our answer is going to be 2/4. Or we can write it as 1/2. Okay, so this is how to solve this problem using a diagram, and now I'm going to show you how to solve it with arithmetic. So we're going to start. Let me erase this actually, just to make some space. So we have 1/4 plus 1/4 again. Since the bottoms are the same, they have the same denominator, we can just add straight across. So 1 plus 1 equals 2 over 4. So the reason we were able to just add straight across is because they had the same number on the bottom. If they had different numbers on the bottom, we would not be able to add across. So as you can see, our answer is the same as before, 2/4. But we could also rewrite it as 1/2. Okay, so that was a pretty basic addition problem. Let's try one that's a little bit harder. So instead of doing one with the same bottoms, we're going to have fractions with different bottoms. So the reason it's important that the bottoms are different is so that we cannot add straight across. We actually have to change the way our fractions look in order to add them. But before we get there, let's solve this problem using our diagram. So what we're going to do is first make a box. And we're going to make a box right next to it. So we're actually making a box to represent each of the fractions. Okay. So for the first box, it is going to equal 1/4. And we're just going to break this box up into 4 different boxes. So 1, 2, 3, 1, 2, 3, 4. So we turn this one whole into 4 separate spots. So that's going to represent our 1/4. And then over here, this box is going to represent our 1/3. So we're going to break this same box into thirds, except this time we are going to make lines that go horizontal. So now this box has 3 different parts, 1, 2, 3. So 3 parts of one whole. Okay, so now how do we add these together? What we're going to do is go ahead and shade in our boxes. So 1/4 is going to be 1 out of the 4 boxes. So I'm going to go ahead and shade that in. Okay, 1/3 is going to be 1 of the 3 boxes. Okay. Oh, this one doesn't shade too well, but you get the point. Okay, so as you can see, we have 1/4 of a whole, we have 1/3 of a whole. So now let's add them together. And how we're going to do this is we're actually going to transcribe our lines from this box onto this one. So we're going to do our 2 lines. So now you can see our box is broken up into thirds, 1, 2, 3, but it's also broken up into fourths, 1, 2, 3, 4. So essentially what we did, we made 12 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we can do the same for this one over here. So we're going to do 4 lines going down. So now we also have 12 boxes. And what we're going to do is we're going to count the shaded boxes of the 12. So if we look here, we have 1, 2, 3. So we have 3 of 12. So I'm actually going to erase this 1/4 and write we have 3 out of 12 boxes. And then we're going to look at this one. So we have 1, 2, 3, 4 out of 12 boxes shaded. So we're going to go ahead, erase our 1/3, and make that 4 out of 12. And amazingly, now we have fractions that have like bottoms, and we can just add straight across the top. So 3 plus 4 is going to equal 7/12. Okay. So that's how you're going to solve it using a diagram, but now I'm going to show you how to do it with arithmetic. Arithmetic is usually a little bit easier, but I always like to start with the diagram just so we have a good understanding of how to do it. So let's remember our 7/12. I'm going to erase everything. So once again, we have 1/4 plus 1/3. We can't add across because the bottoms are not the same. So I'm going to show you how to make the bottoms the same. Okay. So what we're going to do is we're actually going to have to multiply both sides by a number. This is actually where we're going to use our identity theorem. If you remember from before, anything times itself is going to equal itself. So here's 1/4 and here is 1/3. And we're going to multiply both of these by 1. Okay. Oh, that's a multiplication sign. Okay, so we're multiplying both these fractions by 1, so this is not going to change the value of 1/4. 1/4 times 1 is going to equal 1/4. 1/3 times 1 is equal to 1/3. But what we can do, we can change the way the 1 looks without changing its value. So if we instead change our 1 into a 3/3, so if you remember from our identity theorem section, we know that 3/3 is always going to equal 1. We can actually multiply this by 1/4. And this is not going to change the value of 1/4. It's actually just going to change the way it looks. And we can actually do the same with 1/3 over here. So we're going to multiply it by 4/4. Since 4/4 equals 1, when we multiply 1/3 by it, we're not changing the value of 1/3. We're changing the way it looks. Okay. So if you were wondering how I decided to multiply by 4/4 or 3/3, I did this because I know that 3 times 4 is going to equal the same as 3 times 4. So basically what I did, I just chose the numerator of 1/4 and multiplied 1/3 by it, and I took the numerator of 1/3 and multiplied 1/4 by it. We could go more into that later, but I think that will be in a different lesson. So let me go ahead and fix this. And we're going to multiply our fractions through. Okay, so let's look here. We have 3 times 1, so that's going to equal 3. 3 times 4 is going to equal 12. Hopefully you can see that. Yes, okay. Let's do the next problem. 1 times 4 is 4. 3 times 4 is going to be 12. And if you look at that, we now have the same fractions we had in our diagram, and we have the same bottom. So we can add across. 3 plus 4 is going to equal 7. So if you look there, same answer as the diagram, 7/12. Okay, so that's how you add fractions when they have unlike bottoms or different denominators. So let's go ahead and move on to subtracting fractions. So I'm going to clear the board. So let me go ahead and cross off. And we're going to be working on subtracting fractions. So just as they add in fractions, we're going to start with a easier subtraction problem and then go on to a more difficult one. So we're going to go ahead and start with, okay. So we're going to start with 2/3 minus 1/3. We're going to go ahead and start with a diagram again. Once again, this should be very easy. So I'm going to draw a box. Okay, so I drew a box and broke it up into thirds. This box represents one whole. When we break it up into thirds, we can then fill in what our 2/3 represents. So we're going to start with our 2/3. So 1, 2. So 2/3 is 2 of 3. So fill that in. Perfect. And now let's draw a box for our 1/3. Let's do that up here. Okay, fill that in. Okay, this is 1/3. So when we subtract, we're going to take 1/3 away from 2/3. Simple as going like that. Okay, so we took this away from here, and that leaves us with 1/3. There we go. Okay, so 2/3 minus 1/3 is going to equal 1/3. So that's what you do for diagram. Let's go ahead and do it with arithmetic, which should be pretty simple. I'm going to go ahead and erase everything. Okay. Just like addition, when our fractions have the same bottoms, then we can just subtract straight across. So 2/3 minus 1/3 equals 1/3, which is the same as our diagram. Awesome. Okay. So now that we can do that one, let's go ahead and move on to one that's a little bit more difficult. This one's actually going to have different denominators, so the bottoms are going to be different, and we cannot just subtract across the top. We need to change the way our fractions look. So I'm going to go ahead and erase this. 1/3 minus 1/4. Okay, perfect. So this is the problem we're going to approach right now. The bottoms are different, so we can't subtract across the top. So we're going to have to change the way our fractions look in order to solve this. Just as the other problems, I'm going to start by showing you how to solve it with a diagram first. So I'm going to go ahead and draw two different diagrams for this one. So one diagram is going to represent 1/3. The other one's going to represent 1/4. I'm going to go ahead and get my two different colored markers again. And we're going to break this first box up into thirds. Okay. So this box represents one whole, and now it's broken up into 1, 2, 3 different parts. Okay, and let's do the same for 1/4. 2. I am going to use a purple instead, so you can see it better. Oh, a lot better. Okay, so this box represents one whole, and what I did, I divided it into 4 different parts. So 1, 2, 3, 4. And what we're going to do now is shade the sections that represent our fractions. So for our first fraction, we have 1 out of 3, or 1/3. So 1, 2, 3. Let's just shade in one of them. So there's 1/3 of one whole. We're going to do the same for 1/4. Shade in 1/4 of our whole. Okay. But now, how do we subtract these? Because they are still not the same. Well, I'm going to show you how to do that. We're going to take our horizontal lines from this box and translate it across. So 1, 2, 3, 4. So what I did, I took these 3 lines and put them over here. So now we have 1, 2, 3, 4. But we still have our 3 sections too. So 1, 2, 3. And what I'm going to do is do the same for this over here. So I'm going to add our 3 sections to this side. So 1, 2, 3, 1, 2, 3. And we're going to count the boxes that are shaded in because we just made new boxes. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes in total. This is going to be the same on this side too. There's also 12 boxes, and we're going to count the boxes we have shaded in. So we have 1, 2, 3, 4. Let me erase this 1/3. We have 4 out of 12. And then we're going to count the boxes over here. We have 1, 2, 3. Going to erase this. We have 3 out of 12. So now we have fractions with like bottoms, 12 and 12. So we could subtract straight across. 4 minus 3 is going to be 1 over 12. Okay, so that's how we do it with our diagrams. Let me show you how to do it with arithmetic, and then we're going to call it at that. So we're going to do the same problem, except with arithmetic. Okay. So 1/3 minus 1/4 again. So just as addition, we're going to have to multiply these 2 fractions by a number in order to change it in a way that we can subtract. The reason we can't subtract is because the bottoms are different. If they were the same, we'd be able to subtract straight across. So what I'm actually going to do is multiply 1/4 by 1 and 1/3 by 1. So I did 1 times 1/3 and 1/4 times 1. So multiplying by 1 on both sides. But we're going to change the way our 1 looks. So if you remember our identity theorem from before, any number that is over itself is going to equal 1. So 4 over 4 is actually the same as multiplying by 1. So when we multiply 1/3 by 4 over 4, we're actually not changing how much our 1/3 is worth. We're just changing the way it looks. So we're going to do the same on the other side for our 1/4. And we're going to choose 3 over 3. Once again, I just chose the bottom of our opposite fraction to be what we're multiplying by. So we're multiplying 1/3 by 4 over 4, because we got the 4 from right here. And we're multiplying 1/4 by 3 over 3, because we got the 3 from over here. So I'm going to go ahead and multiply these across, and I'll show you what we have. So 4 times 1 is going to be 4. 4 times 3 is going to be 12. 1 times 3 is 3. 4 times 3 is 12. Okay, and since we have like bottoms, now we can subtract straight across. So 4 minus 3 is 1 over 12. Okay, so 4 12ths minus 3 12ths equals 1/12. And if you remember from our diagram, that should be the same answer. So I think that's going to be it today. Cross it off. What we did, we added and subtracted fractions, and we learned about the identity theorem. So thanks so much for joining me in our activity today, and please join us at ymca.org/classroom4all for more classes. See you again soon.
Did you know that YMCA of San Francisco never closed? When shelter-in-place happened, we could no longer provide in-person programming. We quickly shifted to provide youth and family programming virtually. As early as April, we started providing on-demand activities in our YMCA of San Francisco YouTube channel.
For this video, we're going to be making a geodesic dome.
Today, we're going to be making a hovercraft. The science around this activity is really awesome.
In addition, we have a regular schedule of activities for our youth and families to join live. We feature read-alouds, yoga, family Zumba, arts and crafts, drawing clubs, and more. So don't miss out on our virtual youth and family offerings. Visit www.ymcasf.org for more info and class schedules.